7.5 from YUMIN Primary School.
My name is Guo Chengxi, 8.5, also from YUMIN Primary School.
This lesson is Calculus, Chapter 6, Definite Integral. First part, we'll study what is so special about double integration. For double integration, let me just tell you, double integration, triple integration, they're actually all definite integrals.
How come?
And these definite integrals, they have the region, also known as the domain, the boundary. Okay?
Wait, but how come? I got a question for you. That I'll prove that indefinite integrals again. Soundless. I'll prove that not just definite integral can, indefinite integral also can. So one more question.
Like this.
You see, it can solve.
But this is not triple integration.
Like a method. You also can solve.
This is not double integration. This is not triple integration. They
But-
have only one variable. Only one variable, just like you keep integrating. But for the real definite integral, triple integral, they have more than one variable. Like in this case, we have two variables.
Okay.
Triple integration, they have three variables. Okay?
Yes.
So for this, remember, these are actually not considered as double integration and triple integration. Okay?
Okay, now I got it. So this indefinite integral cannot solve these questions.
Okay, well, it's because for that, you don't have the region. Right?
Yes.
So first for this, we'll look at the domain.
Definite.
Yeah, and remember the definite integral.
And you also a double integral.
So right now for this, you can draw your domain over here, and I'll draw mine over here, okay?
But you meant by which domain?
Well, obviously the domain is actually for the boundaries, the region.
Yeah.
Let me just tell you. Okay, first we'll look at this. So start drawing. So actually remember this part is cut off over here. So yeah, we don't need to continue with this part.
Actually, it should be like this, but Yes.
Okay, so yes, correct. You had that part already. And remember just that this is a 1. Do you know why we're actually drawing these out?
We need to find the area.
Yeah, of course we need to find this part area. But let me just tell you, for this we cannot directly solve.
Why?
We have 3 methods that we can use, right?
Yep, partial fraction.
Partial fraction. Can we use in this case?
Nah. Because
One
only one
eliminated. Then after that,
integral by parts.
integral by parts, you think we can use? Cosine x put in become the sine x. And then just get more and more complicated. The other way around, square root x put in. You can't get rid of that square root. Also cannot.
What about substitution?
Substitution. For example, you start cosine x as u. Inside the square root, you'll get an inverse cosine u, which is still trigonometry. Useless.
Actually, not trigonometry, it becomes inverse trigonometry.
But it is still trigonometry. Remember, inverse trigonometry is still trigonometry, okay?
Okay.
So, all the 3 methods are eliminated. But remember, for this double integration, we still have another way. Try the other way. Try to have y first, then x. Let's try, okay?
You meant?
Remember, for this case, well, how do we go?
Okay, so actually, do you mean by putting the y over here, putting the x over here?
Okay, yeah, y first. So
Y
remember, we go
first?
this way. This is how we go, like this, right?
Yeah.
How about the other way, which I'm talking about right now? Can we draw it out what it's like?
Okay. So can you erase those?
No, not erase, draw out what it's like.
Yeah.
Remember, this goes like this.
So it's not about erasing, right?
So yes, correct, it is something like that.
Yeah.
So for this, how can we change it? Of course, here we have this cosine x over square root x. And this is dy. Here is dx. But what are the boundaries?
So the boundary for this is 0 to 1.
Are you sure?
Yes. Y from 1 to square root x to 1.
Are you really sure about that?
Yeah. Yeah. Oh, so this until 0, not until 1.
It is from 0, not until 0.
From 0 to square root x.
Let me just tell you how to determine these.
Constant.
In case you don't know.
Constant.
So let me just tell you, actually for this, you need to look at this graph. So for that y, it is from this line, which is a 0. 0 go all the way to curve. What is this curve? For the y is actually square root x. So it goes all the way to square root x, okay?
Okay.
You don't think it's just from their transfer, okay?
Okay.
So for this, as you said, this is a constant, right? So you can just take it in front here.
Okay.
actually be integrals from 0 to square root x dy. So it's a y sub in like this.
Yes, and the other way is the 0, so no need.
Yes,
Simplify.
correct.
Now 10.
So what did you realize? Can we continue with that? What happened there? It's wrong. Yes, correct. You just missed out that x. So actually the sign 0 is actually a 0, right? So sign 1, what is actually?
You should use about.
So we actually will need to use a calculator for this.
Yes.
And remember, this is actually about 0.8415. 0.8415. Yes. So you realize that the answer is actually just like this. So remember, don't be tricked by these questions that looks complicated. So let me just tell you again.
These questions are lying.
Well, actually, for this, yeah, you can say that there might be lying.
Because it looks so hard, but it's not even hard.
So let me tell you again. This double integration is definite integration.
Indefinite integration cannot solve. Because indefinite integration cannot use that method.
Well, or else it is an indefinite integration that has one variable. Of course, one variable, you can always solve that, right?
Yes.
But also not all the time.
Yes.
So for this, remember, in order for us to be clear of what this will be like, we'll need to draw out this domain.
Okie dokie.
And if we cannot straight away solve, we'll need to draw out what is it like at first and how can we change it into. So it is just something like this. Transform this into an arrow. Becomes like that. Okay?
Okay.
So, are you clear for this so far?
Okay.
Okay, so is there any more other questions? Any more other questions?
No.
So, anything else to say?
If you like our videos, don't forget to subscribe to our channel.
So, we'll end our lesson here. See you in the next lesson.
Okay.
Thank you for your watching.